Hello? 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 I say.
Fuck you.
Hello, hello.
Hello, Prasant.
Hello.
Prasant.
Hello.
Hello. Hello.
Good afternoon. Good afternoon, sir.
I can hear you. Are you able to hear me?
Yes, sir. You are audible, sir.
Okay, fine. You can also see me?
Yeah, we can see you, sir.
Okay. So wait for some time. It will
Sir.
change. Yeah.
Thank you, sir.
Okay. Hello. Prasant. Hello. Prasant. Hello. 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 I can hear you. Are you able to hear me?
Yes, sir, you are audible, sir.
Okay, fine. Prashant, can you see the screen? और तो ठीक है तुमने আসছো না ঠিক আছে Prashant,
Has disappeared again.
now it is coming. It is not working. Now share the screen.
Yes, sir, screen is visible now.
Screen is visible?
Yes, sir.
Okay. Okay. But my voice is audible, na? Clear, na? From your side, the voice is little resounding. You know? It is not very clear. Anyway, if you are able to listen to me, fine.
Sir, are you audible now?
Yeah, I can hear you. Absolutely no problem. Mic doesn't like it. Wait, I guess. Okay. Okay, fine. Minimize the one. Escape. Start. Schematic. This and this. That is it. The screen till I got a point of view.
Sir,
Yeah.
Sir, Manas is here. Yeah.
Manas, where are you now?
Now, sir, in MAD lab, sir.
Okay, okay.
Sir, I think they will, sir, first will introduce you. But then we will start, sir.
Oh, no problem. I am
Okay,
ready.
Okay, sir.
Yeah.
Yeah, so only 5 to 10 minutes, sir.
No problem. No.
Okay, sir. Thank you.
Hello.
Yeah.
Hello.
Yes.
Am I audible?
Yes.
Yes, sir.
Hello.
Am I audible? Yes.
Yes, sir.
Hello. Sondadito da. Hello, Sondadito da.
Yes, sir. You are audible, sir.
Yes. Okay. আমি 1 বজাত লৈছো আমাৰ জয়সাগৰ ঘৰৰ পৰা পটককে হেৰি কৰিলো হয় স্যাৰ আৰম্ভ কৰক আমাৰ ফালৰ পৰা এতিয়া হেৰি এতিয়া আমাৰ আমি ষ্টাৰ্ট কৰিব লৈছো স্যাৰ হ'ব আমি ষ্টাৰ্ট কৰিব লৈছো আমি 1 বজাত লৈছো আমাৰ জয়সাগৰ ঘৰৰ পটককে হেৰি কৰিলো আমাৰ ফালৰ পৰা
Geology department or Kibata. So that it is Kumala Baba. My network to be at there. Hello.
Sir, the chairperson of today's program and the principal of Gurgaon College. Respected Professor Gogoi, sir, the convener of today's program and the HOD of Department of Geology. Honorable resource person, Professor Eminent Professor of Department of Art Science, IIT Bombay. Excellent faculty member of Department of Geology. Respected teachers, dear participants, beloved juniors, and my dear friends, a very good afternoon to all. My on the behalf of organizing committee, take the opportunity of welcome you all to today's program to celebrate World Geologist Day. The day is dedicated to celebrate our esteemed friends, to understand our running on our art, the history as well as the course number. Today is dedicated to celebrate our achievement in the particular branches of science, that is geoscience, which is enable us to understand the different processes running on our mother earth, the history as well as the future implications. On the occasion, we are thankful to Professor Tk Viswal sir for agreeing to enlighten us with a highly resourceful talk to grace the session. To give a brief background of the World Geologist Day, established the World Geologist Day in 1966. The day is popular. The day popularity is ultimately crossed the borders of Soviet Union and spread worldwide. Although the World Geologist Day is celebrated globally on the first Sunday of April, we are arranging it in a blended mode. So participants from different institutions have shown interest to attend this session. Therefore, we are arranging today, that is 4th April 2022. We are glad to invite the participants from different places of Assam as well as India, including Aligarh Muslim University, Assam University Silchar, MIT Durgapur, University of Lucknow, Assam University Silchar, Uttarakhand University, Central University of Karnataka, Raipur, Naresh Chauhan, Government College, Chandrapur, Dibrugarh University, and many more colleges and institutions to this program. The basic goal of today's program is to inspire the next generation to super geologists in the making. Now I would like to request our chairperson and Honorary Principal, Dr. Sabruti Mahanta sir, to say a few words to break the session.
Thank you so much. A very good afternoon to you all. Professor Sondraditya Gogoi, HOD of Department of Geology, Gurgaon College, Professor Tk Viswal, an eminent geologist from IIT Bombay, respected teachers, and dear participants. I would like to offer my sincere thanks and gratitude to the Department of Geology for holding the seminar, the webinar on the occasion of World Geologist Day, the webinar on fundamentals of structural geology and its career prospects. And on the occasion of World Geologist Day, I would offer my best wishes and regards to all the participants participating in this webinar. And I would also like to welcome all the participants, and especially Professor Tk Viswal from IIT Bombay, who has given the consent to be present here and deliver a speech on development of fold, fault, and ductile shear zone on the occasion of World Geologist Day. And I would like to appreciate the endeavor and initiative that has been taken by the Department of Geology, Gorgaon College, to mark the occasion of World Geologist Day. This is indeed a splendid job, and I also hope the speech that would be delivered by Professor Tk Viswal will benefit our students, research scholars, and the faculty members as well in formulating their ideas or formulating their methodology in research in fundamental structural geology. And wish you all the best. Hope this event would be a grand success. And in this, with these few words, I would like to welcome you all, and I declare the session is open. Thank you so much.
Thank you so much, sir, for your valuable and motivating speech. We would like to show our sincere gratitude to you for your valuable support and encouragement to arrange this event. Now I would like to request Mr. Manas Pradeep Saikia, sir, to introduce our resource person to take over the program. Thank you.
Excuse me, I would like to say a few words again. Actually, I am at Dergaon, DKD College, Dergaon. Actually, the Dibrugarh University Inter-College Youth Festival is going on in DKD College, Dergaon. And I, with Dr. Pawan Gogoi, have arrived in DKD College to cheer up our students, our participants representing Gorgaon College. So I am really very sorry I would not be able to continue with you in the session. So I am taking permission from you for leaving the meeting. Thank you so much, and this would be a grand success, I hope. Thank you.
Thank you, sir. Thank you.
Thank you so much.
So thank you. For first of all, happy Geologist Day to all. Now let me introduce Professor Tk Viswal, sir. Am I audible?
Yes, yes.
Okay. So Professor Tk Viswal is an eminent professor from the Department of Earth Science, IIT Bombay. Professor Viswal has been teaching structural geology, tectonics, structural analysis, Precambrian geology, and climate geology at IIT Bombay for MSc, MTech, and PhD students. Professor Viswal is well known for his expertise in the field of structural geology and tectonics, as well as profound research contribution in his field. Professor Viswal has published more than 100 of research publications, book chapters, and conference papers in reputed national and international journals. He has also achieved many awards and recognition, including prestigious National Mineral Award from Ministry of Mines, Government of India, New Delhi in Basic Geosciences, 2008, awarded in 2010, and Excellence in Teaching Award in 2010, 2014, and 2016 at IIT Bombay. Moreover, sir is very down to earth personality. That's personally I have to recognize. And today, I proudly say that I have been associated with sir for more than 6 years, and it is a great opportunity for the students of Gorgaon College to attend his lecture. Now, I would like to request Professor Tk Viswal to kindly proceed with his speech.
Okay. Thank you, Manas, for kind introduction.
Thank you, sir.
As well as, actually, a teacher doesn't require introduction before the batch of students, because students are always close to his heart. Anyway, I have been, as you told, I have been teaching the structural geology, tectonics, recently climate geology. All these branches I am teaching. But the most favorite subject which I enjoy, is the field geology. Because I was in Geological Survey of India for many years. For 13 years, I was working there. So, ins and out, the difficulties and facilities that a field geologist experience in the field, so I know it. That is why sometimes I feel our younger generation should go for this type of job. Those who are in the audience today, the students, I should suggest them. There may be other branches which are job facing, but geologist is such a job which you will enjoy to the core of your heart. Though little hard, because you will be staying in the field. Though it is little hard, and sometimes you will feel isolated because you will be alone in the field with a jeep, with few people around you. But if you are really involved in geological work, you will enjoy like anything. Because geology is a subject which has no end. See, this India is being mapped or being studied for last so many years, 100, 200 years, but still it is new. Tomorrow, if you join some geologist organization, some geological organization, you will feel starting something new work in the same area where many people have worked. That is why I always suggest the students, you join a geologist job. And if you are a good students, which you can make your career very bright, you better go through some decent literature, decent books. You will update your knowledge. You can become a good students, and you can join some good job, and you will enjoy the profession. So that is my suggestion. And today, actually it was yesterday, the World's Geologist Day. It was started in 1966 by Soviet geologists just to commemorate or just to celebrate, their finding of oil reservoir in Siberia. So you see how today oil is being used by everyone. And those countries where oils are maximum in the reserve, they are strategic countries. So who has contributed for this status? It is the geologist community which has given this status to those countries. Why Russia is so powerful? Why US is so powerful? Or Middle East is so powerful? It is because of the oil. And oil, who has discovered? The geologists have discovered. Similarly, other things like gold, platinum, uranium, these are also very strategic minerals. So who has discovered all these things? The geologists. So it is very hard to discover them. It is very hard to stay in the field months together, work very systematically, apply your mind to full active mind to your work. It is very difficult, but the result is very pleasant. Once you get some outcrop or once you get some prospect, you will be recognized across the world, across the country like anything. So these are my suggestions on this World's Geologist Day. I think some of you will be encouraged to pursue this line. So since I am a structural geologist, so naturally I will share my thought and knowledge about the structural geology. But in between, I will be telling something outside structural geology also, as I do it in the classrooms, So let me share my screen. Is it coming? Is it okay? My screen is being visible. Manas or Prakash, my screen is visible?
Yes, sir. Your screen is visible.
Okay. So, okay. So this is World Geologist Day. Since some of you are in the BC level, they should also know geology. This was first celebrated by the Soviet geologists in 1966, and it is being celebrated on the first Sunday of April. So, in fact, yesterday it was the Geologist Day, but since we are organizing a webinar, today also you can assume it to be World Geologist Day. Then geology is a very natural science. I will tell something about it. Geology is a very much natural science. In the sense, it has the component of physics. We read about the composition of the earth. So that composition of the earth, the most of the data, most of the idea is being proven by the physicists or geophysicists, what we say. Because we do not see the earth interior by ourselves. So from propagating some waves, we understand the rock types, its status, all those things we interpret on basis of some geophysical study. So it is a geophysics component. Similarly, the chemistry, we do geochemistry of the rock. We say granite is silica rich. We say basalt is silica poor. How could you know? because we have to analyze it. Just like a chemist, he analyzes his samples, we also analyze. So you should know good amount of chemistry. Similarly, biology. Biology is very much essential because we also deal with lives in the olden times, like during Paleozoic times. What are the life? We see some fossils in the rock and we interpret how was the life. So like this, we have borrowed the things from different branches of science and we have enriched the geology. And similarly, you see nowadays people talk about climate science, how climate is changing. Now, though it is being done by atmospheric science people or oceanic science people, but ultimately it goes to the subject geology. Suppose somebody asks why there is acidification of the ocean. Who will tell acidification of the ocean? What is the acidification of the ocean? What is the aragonite compensation depth? All these things are in geology only. But we apply how the oceanic water is being acidified, carbon dioxide dissolution or whatever. So geology borrows, or geology has this component of geochemistry, biology, mathematics, physics, oceanic sciences, atmospheric sciences. All branches of science has been incorporated in this geology. So he's telling James Hutton is the father of modern structural geology. Modern geology. Yeah, definitely he is the first person who observed, nature. Why the cliffs are formed along the sea coast in England, Scotland? He first observed there are some sea cliffs. The sea cliffs are consisting of very horizontally bedded rocks, and below the horizontally bedded rocks are vertical. First time he observed. Then he found why it is so. Why vertically bedded rocks are being overlain by the horizontally bedded rocks? So where are they formed? Why one is vertical, why another is horizontal? So the concept of unconformity is given, James Hutton. So later on, the Charles Lyell carried over, defining the natural science called geology. Sometimes I teach in the class, we see moon every day. We see moon every day. Moon is rotating around Earth. Why do you see one side of the moon always, not the other side? So there, you see how geological concept is very important. See, answer you will get in a book. Answer you will get in a book. In the book it is written, you will see one side of the moon because the revolution and rotation speed of the moon is same. But what does it mean? So to understand the meaning, you should have a good background in geology, how when mother is rotating his child, around Earth, why the child face is remaining towards you always. Like, Earth is rotating the moon, like a mother is rotating the baby around her. So definitely child's face will be towards you. So like this, so many branches, so many natural observations, so many natural events are incorporated in the geology. That is why geology is so enjoyable. If you read physics, good. Physics subject is very good, but it's only physics, chemistry, math. But you read geology, you will get the smell of mathematics, physics, chemistry, biology, astronomy, everything and whatnot. That is why it is so enjoyable. So we'll go to the next slide. So geology has several branches. So this you must have read in your PhD days. So the structural geology, tectonics, petrology, economic geology. So different branches are there. Recently, the most important is geochronology and isotope geology. How to find the age of a rock. So this is the most advanced subject now. Most of the geologists are dealing. Many universities across the country, they are having the instruments to date a rock, to find the age of a rock. That is called a geochronometer. So IIT Bombay is having two other departments, IIT Kharagpur. Many places, you will find this type of geochronometer to find the age of a rock. So all these things, has enriched the subject geology. Enriched in the sense, you can accurately date the age of a rock. You can accurately find the cause of earthquake. you can accurately find the composition of a rock because of the instruments arrival. Now sophisticated instruments have come. You can find up to 3 decimal the composition of a rock, up to 2 decimal the age of a rock. Very accurately you can determine that. Then you can allot them to a period or eon or era. So that is because of these instruments. So once you go through this subject or go through this course, you will be exposed to this type of instruments. And if you take up a research outside the country, like US or UK or even Russia, it is an excellent. They have still advanced sophisticated instruments, and they have larger facility. So the geology will be very enjoyable there, and you will be counted one of the advanced geologists in the world. So that is why I always advise my students, to go for this branch. Don't look at the other side of the coin, Other side of coin is only 50%. The rest 50% is enjoyable. That we enjoy. The field hardship, field laborious field work, they are part of our life. We should enjoy that. See, many people are working in marine geology, Antarctic geology. Then nowadays the people are working on lunar rocks. So how they are working in Antarctica, they have to stay months together in this cold environment, but they enjoy. Marine geology, they move in the ship for months together, but they enjoy it. The type of data they collect is so accurate, so valuable, they can build definitely different stories. Okay, now we'll come to structural geology and tectonics, where I have suggested, we will discuss today these 3 things: cold, fault, and ductile stuff. Very briefly, I will tell you. I will not also go very hard part of these subjects. Very easy subjects I will tell, so that you can further read it, you can further analyze it. Now, these are the 3 important elements, cold, fault, and ductile stones. The 3 important elements of structural geology. So you see the first photograph, A group of, these are all IIT Bombay, IIT Bhubaneswar students standing near a hill in Aravalli mountain. So I have taken them to the field work. So you can see the rock is folded, the white layers. You can see the white quartz veins. So they are quartz veins. The quartz veins are folded. See, there are antiforms, there are synforms. The students are with their notebook, they are measuring it. You see, they do not have a shoe, because we crossed a river. We crossed the river and went to the other side. It is December. Water was very cold, but they are very smiley, very enjoying the field work. So the fold, you see, what I am telling here, this fold is very old. Some Proterozoic age rocks. Fold is very old. Now, when you see a fold, the interpretation is it is a ductile structure. Fold is a ductile structure. Ductile structure means what? Ductile structure means the rocks which you are seeing today on the surface was not here when the fold was developed in it. It was some 20 kilometers below or 15 kilometers below the surface. When you take a rock 15 kilometers or 20 kilometers below a surface, it is heated, it is under pressure, so the rock starts melting. Very soft, it becomes very soft. Just like a duff, when you prepare chapati, how is the material? Material is very soft. So the rock becomes like a chapati material. So when it becomes like a chapati material, when you press it, so the chapati becomes rounded. Some people make it elongated, some people make rectangular, different shapes you give. Similarly, these rock which you are seeing a fold, these students are standing there, those structures or those rocks were in a very soft state, which you say is ductile. Because of this ductility, when you press it, when you press from both sides, the folds are developed. So those folds you see today, because when the material is ductile and you press it, folds develop, but it does not go back to its original position. So जो fold हो गया, when it is developed a fold, it is a fold. It cannot become a straight again because this is ductile material. So this rock has become ductile and folded, then solidified, then become hard. So the fold is preserved there. So next time when you go to field and you see some fold, you always take it that the rock where the folds are present, they are ductile during the time of folding. When the folding took place, that time the material was ductile. So that is a ductile structure. Where does it develop? This develops on 15 to 20 kilometer depth. Not on the surface. Now you are seeing at the surface. They have been brought up. The process is called exhumation. Exhumation brings the rock up. Now you see the second photograph. Second photograph is a fault. The scale is kept there. The white band has been faulted. The white band has been faulted. I'll just show you pointer option. You see, here is a fault. This is a fault. The white layer you see has been offset. Here also white layer has been offset. So there are so many, several such faults are there. So these are called fault. If you see a fault in the field, what is the state of the material? They are called brittle. Brittle. Because these faults develop near surface. Near the surface, within 5 kilometers. Temperature is not high enough. Pressure is not high enough. So they develop this type of brittle structures or fault. The example I'll give you, suppose you have a chalk. In your class, you know, when your teacher is writing on the blackboard, you see how many times he breaks chalk. Because chalk is brittle. It is not ductile. It is brittle. So he is developing a fault in it. By breaking a chalk, he is developing a fault in it. So faults are brittle structures. So when you press a chalk, it breaks. If the material is ductile, fold will develop. If material is brittle, fault will develop. So fault will develop near surface, fold will develop below, 20 kilometer, 15 kilometer below. Because you require some temperature and pressure. Now you see the third photograph. Third photograph, you can see it is a granite. It is a granite. The scale is kept here. Here, if you see, you know, there are some planar fabrics. You see, planar fabric. Some cystosity type of things are developed along a narrow zone. If you see a zone like this, narrow zone where some alignment has taken place. But outside you go, there is no such alignment. Only along a narrow zone, there is a alignment. So this alignment, you know, is indication of a fault, but in ductile state. It is a fault, but it is not a brittle fault. Brittle fault where the displacement will be taken. One part will be different from the other. But in case of a ductile fault, there will not be complete detachment. Complete detachment is not possible because this rock was also at depth. 15 kilometer, 20 kilometer depth. So a fault developed there. That fault is not a fault you see in the picture B. In picture C, it is a ductile fault. Why it is a ductile fault? Because some planar fabric or planar surface is developed. Rocks are deformed in a ductile manner along a narrow zone. So you say this ductile fault as ductile shear. So ductile shear zone is now nothing but a fault, but faulting has taken place in a ductile situation or ductile fault. Whereas a fault is a brittle structure, it develops in the upper part of the crust. Ductile shear zone develops at the deeper part of the crust, and faults also develops at the deeper part of the crust. So faults and shear zones, they go side by side. Whereas, faults and the shear zones, but faults are shallow. Faults are very shallow. So this is the difference between faults and shear zones. Many times, if you go for an interview, they ask, what is the basic difference between fault and fault? So you can start. Fault is a ductile structure. Fault is a brittle structure. The interviewer will become very happy. But if you say fault is like this, fault is like this, that is the geometric description. But genetic distinction, what is the genetic distinction? One develops in the ductile situation, another develops in the brittle situation. Distinction. So if you remember these things, then your field work will be very easier. Suppose these students who are moving there, they are seeing many such folds. So in their mind it is going, I am moving over a ductile rock. So there will be folds, there will be ductile shear zones, but there won't be any fault. Yes, that is the thing. Okay. So next go to the other side. So here I am showing some folds to you. See, in BSc generally, those who are in BSc now, they must be reading, classification of the folds. Classification of the folds. But remember, classification of the folds you can learn, you can read in the books. But can you identify the axial plane of the fold? Can you identify the axis of a fold? So that is why I have kept many such photographs. What are different features associated with a fold? Unless you know that, so in the field, what you will see? I saw a person standing there. So whether the person has two hands, whether the person has a turban, whether the person is wearing a shoe, all those things you should know, or all these things you should be able to detect. A person is standing below a tree. How does it matter? Unless you are able to see what are the things with the person. Is he with a cow? Is he with a goat? So like that. So you may see a fold in the field, but what you should do? You should have a clinometer, you should have a field notebook to measure its axial plane, measure its axis. Like you see the first photograph, you see how beautiful it is shown there. The scale is kept parallel to axial plane of the fold. See the axial plane. So axial plane divides the fold into two parts. Now, which is the axis? Now you can see this hinge zone. This is the hinge zone. So axis is down deep, going inside axis. So you should know how to measure the fold axis also. Fold axis, how to measure. Axial plane, how to measure. So these are the fundamentals in the field study. So you should, when we go for field work, you should be after your guide, or whoever takes you to the field, to make it very clear how to measure the axial plane, how to measure the axis. Very much essential. Okay. Now you come to B photograph. It is a very broad fold, open fold, like this, open fold. And at the center, there is a quartz vein going like this. Quartz vein is going like this. It is cross-cutting. It is cross-cutting the fold axial plane. So along the axial plane of the fold, a quartz vein is intruding. So how interesting it is. Now, this fold is like this. So there must be pressure from top and bottom, from this side and this side. So fold is developed. Now, if there is compression from this side and this side, how a quartz vein entered like this? How a quartz vein is entering like this? So this quartz vein must have gone through a lot of compressive stress. Because from both ends you are pressing, and quartz vein is not obeying your compression, it is going through it, cross-cutting it. So the quartz vein must have faced a terrible compression. That is why you see the quartz vein is detached, broken into pieces. You see, it is broken into pieces. So much of compression, broken into pieces, which you say these are buddings. This is a budding, this is a budding, this is a budding. So this photograph will tell so many things to you. You have a fold. This is the compression direction. There is a quartz vein along the axial plane. The quartz vein has been buddinized. Buddings have developed. Why buddings are developed? Because you are compressing from both sides. So it is being detached into small pieces. That is why it is buddinized. So those things will come to your mind. So you have to note down in the figure. Okay. Now come to figure C. See, you see, the fold axis is almost vertical. The fold axis, like the lines you can see, the fold axis is almost vertical. It is a vertical fold. And if you come to D, you see, the scale, the pencil is kept parallel to axial plane of the fold. And can you see the fractures? This is a fracture, this is a fracture. Fractures are developing parallel to axial plane of a fold. So when there are fractures, so naturally the quartz vein will enter into it. So because of those fractures are there in photograph number B, this quartz vein entered through it. And because of the compression, the quartz vein got buddinized. So these are the interpretation you are making out of seeing these structures in the field. Now this will carry forward. How you are going to place it and what are your interpretation and what it is going to give you. We will see in the next photo. Now you see, here there are three folds I am showing you. This fold you see, I have kept a coin, I have kept a pencil, I have kept a scale. So while taking the photographs, you should have all these things with you. You should carry a good pen or pencil, colorful. You should have some coin. You should have a scale, diagonal scale it is called. So all these things, are used to indicate some features in the field. Like pencil is kept near a fold, the coin is kept near another fold, and scale is kept parallel to axial plane. So these things you should note down in your notebook. This is how you should describe a fold. Similarly, come to B. B is a recumbent fold. Axial plane is horizontal. Axial plane is horizontal, so it is a recumbent. Now you come to picture C. See, there are white bands, dark bands. You can see these white bands and dark band rocks. Gneiss. Gneiss. This is called a gneiss. So this happens in a migmatite. Migmatite means rock is partially melted. As I told you, these are ductile structures developed at a depth of the crust. So rock is melted because of high temperature. So this rock melting has taken place. So that is why it is called a migmatite or gneiss. And you can see the pencil, the pen is kept very close. There is a fracture. Fracture is developed parallel to axial plane of the fold. There is another fracture parallel to axial plane of the fold. So all these things you should note in the field diagram. Although later on, you may require all this data for interpretation. What is the importance of this fracture? What is the importance of a recombinant fold? All those things you can do provided you observe all these things and record all those things in the field itself. Okay. Now, these are some interference patterns I have shown, because in BSc generally interference patterns are not covered. So the interference patterns are those things, when there are faults of different generations. Like suppose in Aravalli mountain belt or Himalayan mountain belt. So Himalayan mountain belt, what is the age? Age is something, say, some 40 to 20 million. It started 40 million years back and continued up to 20 million years. So 40, 45, 40, 35, 30, different period, there is some compression, some folds are developed. 30 million years, some fold developed. 25 million years, some fold developed. So this sequence of folds, earliest to youngest, they superimpose one over the other. When they superimpose one over the other, you find the interference pattern. So first A is a dome, domal outflow. B, it is called a mirror image pattern. C is called a coaxial folding. So depending on how the earlier fold and the late folds are positioned, how is the axial plane of early fold, how is the axial plane of late fold, you can find a dome and basin, you can find a mirror image, you can find a coaxial fold. So this indicates, when you find a interference pattern, this implies that there are different generations of people name them as F1, F2, F3, F4. So in a mountain belt, it is quite easy to recognize or to find folds up to 4th generation, 5th generation. So when we work in Aravalli mountain, so I used to show all the students, you see how to identify F1, first, how to identify a second fold, how to identify a third fold. So those identification is very important. But if you have a trained teacher with you, he will tell you this is F1, this is F2, and in 1 or 2 days, you will be master in identifying the fold and the interference pattern. It is not difficult, but somebody has to show that this is first fold, this is second fold. That is the thing. Nothing very difficult. Now you see variety of folded structures. You'll be thrilled to see some outcrops. You see the first one, the boy is sitting, he is Rudra. Rudra is sitting on a outcrop. Do you feel he is happy or unhappy? He is very happy, he is looking very happy. Another student is standing behind. They are very happy. Why? When they see a structure or a outcrop like this, so many folds, quartz veins, so clean outcrop, your heart becomes thrilled. Such beautiful structures are there in the rock even. Rock has produced sometimes, during your birthday party, we decorate our home. We put a light here, we put another flower here, we put some balloon here. Ultimately, it is just a mess. Some people say, it is very good arrangement. Some people say, no, it should have been there, it should have been there. But you see the nature? Nature has developed very perfect. Everybody likes it. So that is why I am telling you. So if you know how to do field work, how to measure the rocks, how to measure the axial plane of the fold, how to measure the axis of the fold, then outcrop will become very close to you. You will enjoy looking at the outcrops. They go to second photograph. Second photograph, so many quartz veins. So many quartz veins inside marble. The rock is a marble. If you put some acid, hydrochloric acid, it will ferment. It will react. Now, inside that you have a quartz. Quartz veins are folded. I told you in the first photograph, you are now dealing with a rock which was 20 kilometers below. They were not at the surface. Now they have come to the surface because of excision. Okay. Now you come to the photograph number C. Then you see the folds, very small folds. You see, very small folds. They are called stigmatic folds. Stigmatic folds. These stigmatic folds, such a small wavelength. Wavelength you understand by now because you must have read some basics of structural geology. This is a wavy form, so it has a wavelength. So wavelength is very small of a stigmatic. Now this tells one more thing. There is a law called Biot's law of buckling. Biot's law of buckling. This indicates if a layer is very thin, like the one which you are seeing here, it's a very thin layer. The thin layer will be folded with folds of smaller wavelength. If layer is thick, it will be folded with folds of larger wavelength. This is called Biot's law of buckling. Buckling means folding. So stigmatic fold follows the Biot's law of buckling. Come to the figure D. D is granulation cleavage. Granulation cleavage. Crinkles. Granulation. Very sharp means the folds. So it has name. It has name like granulation. It is a stigmatic fold. That is a parallel fold. That is a recombinant fold, isoclinal fold. So these are the identifications. Naming of a fold. So you should be acquainted with those names. Otherwise, what? You went to some village or countryside, you found a person standing there. How does it matter? You should ask, what is your name? How many children you have? How many brothers, sisters you have? Then only you can identify him. The way we are making our Aadhaar card. Like that. So if you see a fold, how does it matter? What type of fold it is? You should give a name to it. What is the axial plane? You should measure it. What is the axis? You should measure it and note it. So if you can do all these things, then only your study will be complete. And it is not a very big or difficult exercise. Anybody can do. Only you should be trained in the field. How to do it, how to identify it, how to take a photograph. So if you know, then you will do, you will jump over it. You will jump over it. Okay. Now, this is something different, Here is the geological map. The most important job of a field geologist is to produce a geological map. Geological map, this your boss, this your, when you publish a paper, the reviewer will see this. How beautiful, how scientific, how clearly you have drawn a map. What are the standard of geological data you have put it? I told you what is the geological data, axial plane strike, axis strike. So how attractive is your map? So this map we have, this is the geological map of Ambaji region, Gujarat. This map we have published in several papers. A very good looking map. You see this map, we have given different colors to it. Colors are also again standards. So there is a quartzite rock, yellow symbol you have to give. If it is a granite, some pink color you have to give. Like this, some standard colors are there. So you should use them. So a geological map should consist of lithology, rocks, and second, the data. The axial plane, axis, some fault is there, the orientation of the fault, the slicken lines on a fault, all those things, should be plotted on a map. Map should carry all these data. Then only it is a complete map. So that is what we have done. The geological map we have prepared, both lithology as well as the structural data. Now, why I am showing these things? You just come to the next slide. Now, see the photograph. This is the hill. Quite big hill, not very big, quite big hill. There is a babul plant, Rajasthan is famous for babul trees. Unlike Assam or other areas where you have a lot of rainfall. So you have bushy trees. You have very big trees. You have a lot of rainfall. But in Rajasthan, no rainfall. So only you will get this type of thorny trees. Now, because of these thorny trees, because of lack of undergrowth, there is no grass. You can see the outcrops completely. You see the outcrops, everything, inch by inch you can see. But if you do field work in Nagaland, if you do field work in Assam, like, very interior part you go, there will be trees, grass, there are not many outcrops. And if there is an outcrop, it will roll. So, doing field work in Rajasthan, Gujarat, part of Madhya Pradesh is very interesting. All the rocks are preserved. You can measure anything. You can take photographs of everything. So here what I am showing. Now, if there is a very big fold like this, what will you do? You cannot do a small scale work. So you have to measure the strike depth here, you should make a strike depth here, strike depth here. All around the fold you measure strike depth. Now after measuring the strike depth all over the fold, you plot in a stereo net. Stereo net is a very important exercise in geological mapping. Whatever data you are collecting in the field, you put it in a stereo net. The techniques are very easy. It is much easier than what the difficulty you face while wearing a shirt or pant. It is much easier. Within, say, 1 hour, you can complete a stereo net like this. Very easy. Now the softwares have come. But even if you do manually, it is so easy and less time. But it provides very important information. Now the fold which you are seeing here, what is its axial plane, what is its axis, you cannot measure it. It is a large scale fold. Unlike the other folds which I was showing earlier, there you can measure with a Bunton compass or a Kleino compass, its axial plane and axis. Here you cannot measure that because it is a large scale fold. So you have to take data from here continuously and put it in a stereo net. Then you have to contour it. Then you have to draw a girdle. This is the girdle. This is the girdle. Then girdle, the pole of the girdle is beta axis. It is called beta axis. Beta axis is the fold axis. The fold which you are seeing in this photograph, the axis of the fold is beta axis. This one. So this stereo net exercise, the stereo plot exercise is a very important part of field geology. Not only here, you will find the use of stereo net in fault. You will find the stereo net exercises in earthquake, what not. The polar wonder part in tectonics. But it gives a lot of immense information it gives to you, but the methodology is very easy. How to plot a plane or a line in a stereo net. So I have made a YouTube video how to plot structural data in stereo net. Just write Tk Viswal YouTube stereo net. I have explained very smaller bits by bits. I have explained about the plotting of the stereo nets. You can learn it. You need not have to go through any book. You just see it once. The process is very easy. And wherever you do not understand, you repeat it. Even after that, if you cannot understand, you write a mail to me. What you have told, we are unable to understand. I will very happily reply your mail. Absolutely no problem. But you should know how to plot a stereo. That is the basic part of it. Okay. Now, here comes. Once we have gone for field work to Aravalli, the villagers, when they see you, they will ask, sir, what for you have come here? What are you seeing in this rock? They do not understand this is a bedding plane, this is a fold axis, this is a fold. They do not understand. What they understand, you know, are you finding some minerals like gold, some copper, lead, zinc? Are you finding something like that from this rock? Because this knowledge they have. All these metallic minerals now are from this rock style. That they know. Because this is not today's practice. That the rocks are the household. The rocks are the real holder of all these minerals, metallic minerals. The peoples, in maybe thousands centuries that time, they have understood it. Now we are only defining it scientifically. So when are you going for studying the folds, you know, you always keep in mind, are you moving over a highly quartz veneted area? The lithology rocks, you just leave it. Like see photo, fast photo. This is a mica schist or a phyllite. But you see, there are some quartz pockets in it. Quartz pockets. Second photograph, see, this is a fold, but you see a quartz pocket in it. So these are called saddle ribs. At the hinge zone of the fold, there will be pockets of quartz. This is not a part of this original rock. This has come from outside. Later, during folding, it has come and being deposited in the fold hinge. The fold hinge, they have deposited. So this is called a saddle rib. So you should be able to see the saddle ribs. And if you find some saddle ribs, blindly collect sample from that quartz bed and analyze it in the laboratory. You will find some sulfides, lead, zinc, sometimes gold also you will find in these saddle ribs. So you should know the geology first. A fold, hinge zone, saddle rib. Otherwise, where from you will collect the sample? Quartz vein from road will not help you. You should go to a saddle rib zone and take a quartzite or quartz vein sample. So these two photographs I'm showing, keep in mind that saddle ribs are very important for metallic minerals. Those metallic minerals, they stay inside the quartz vein. You should not lose them. Okay. Another place. So we see a big fold. These are the limbs. These are the limbs. Here I am not talking about the saddle reef. Saddle reef is the hinge on quartz vein. But these are ladder vein. We use a ladder to climb up a hill, climb up a wall, climb up a electric pole. So those are the ladder veins. You see, these are the ladder veins. They form on the limb region. So these type of structures you should keep your eye open. They develop on the limb region of a big fold. Immediately collect the samples. Immediately collect the samples and send for analysis. For these elements, like copper, lead, zinc, the molybdenum, titanium, Re, gold, platinum, they will be there in this quartz veins. Invariably, see, I'll tell you the concentration may be high or low, but they contain these minerals. But you should know what is the science. Where is the fold, where is the ladder? You should first of all know. Then only your work will be good. Otherwise, how it will be good? Ladder veins. Now, I remember, there is a place in Rajasthan called Jawar. Jawar, Jawar. Famous for lead zinc deposit. Very close to Udaipur. And this deposit is being mined right from Rana Pratap time. Very king's time. But till today, the mine is existing. And where are they mining? They only go for these quartz veins, the ladder veins. saddle reefs. So number of geologists are posted there. Some of them are from maybe from your place. They are working there. Their only job is find a fold, find the ladder vein, find the saddle reef, and send for analysis. Very rich deposit, lead and zinc. So that is the thing. That is the story. So you should know the structure. Okay. So this is another quartz vein. In the field, if you find quartz vein, just don't leave that spot. Try to sample it for mineral analysis. See the quartz veins. Here you see there are folds, but there are some dolerite dikes. You can see the dolerite dikes. A hammer is kept here, dolerite dikes, parallel to axial plane of the fold. The dolerite dikes you see, you just put a magnet over it. It will not leave your magnet. It will catch. Take a powder from this dolerite, bring it to magnet. All those powders will stick to the magnet. This is magnetite. Ilmenite. These dikes. So they have come during folding. So now, if you are working in a folded terrain, look for the dolerite dikes. For magnetite and ilmenites. Ilmenites are thorium. Magnetites, iron. You should be able to identify. Okay. So this is all about the fold, you know. Fold, quartz vein, and the minerals. Now let us go to fault. Fault, I told you, these are brittle structures. Now you just see the photographs. First photograph you see. You see this red band. Red band is a BIF band. Banded iron formation. So see how the shifting has taken place. Shifting. Now the rock has been shifted horizontal manner. This block has gone this side. So this is the fault plane. Now you come to the second photograph B. This is a limestone. You see the fault. You see the fault. This block has gone up and this block has come down. So this is a horizontal fault. This is almost a vertical fault. This is a normal fault. But you come to this core box. Core, you see the fault. You see the fault here. Displacement is taking place. This is, you see the fault. Displacement has taken place. So this is a thrust. Because this hanging wall has gone up. Hanging wall has gone up. This is a thrust. This is a thrust. So you have normal fault and thrust. You see, here the rock is broken into pieces. See, it is sharply broken. Because this is a brittle structure. Top part of the crust, this deformation has taken place. So it is a brittle state. Okay. Now, you see the fault. Here, fantastic faults are there. You see, first photograph. You see, complete detachment. There is no connection at all. From here, this part has gone down, this part has gone. So this is also a normal fault. Here also see the normal fault. Here you see normal fault. You see how it is broken. Two pieces, this band and this band has been broken. So these are normal faults. Now let us go to R. You see the fault, very close space fault. You see, yes. See. So this is not a book self gliding. So in your room or in the hostel, you must have kept the books. So when you tilt it, you said it is a book self gliding or domino. One tilts, it makes other tilt, that makes other tilt. So this fault is a normal fault, but it is some sort of bookshelf lighting structure. In a faulted area, we say it is a bookshelf lighting structure. Okay. Now, you see this photograph very carefully. Now see, here is a fault. You see this black mark, and black mark is here. This has been offset. This is the fault. Along the fault, the rock has been crushed, brecciated. It is called brecciated zone. You see small fragments. You see small fragments. It is the brecciated zone, or you say the brexia. And the sidewise photograph you see hammer is kept, and this zone you see, this zone, brecciated. Along the fault, rock is crushed. Small fragments are developed. This is called a brecciated zone. And you know, these brecciated zones, the rock becomes porous. Rock becomes cavernous, because cavities develop here. So along this brecciated zone, the mineral fluid, if there is a mineralizing fluid source is there, the mineralizing fluid goes into it, and different minerals you will find. The most important is uranium. Uranium along the fault. Lead zinc mineralization along the fault takes place. So you should look for a brecciated zone in the fault. Okay. Now see, number of faults are there. These quartz veins are entering along those faults. So these are mineralized. These are the mineralized quartz veins. So what the field geologists they do? That goes on collecting the samples and analyze them. Okay. Here it is a different, little advanced diagram, a little out of focus, you know. I was downloading from internet. Otherwise, most of the slides are my collections. This was from some bookers from a web source I have collected. That is why it is little out of focus. So these folds which are seen here, these folds are called fault band fold or fault propagation. These are a little higher level. In Himalaya, these type of folds are very plenty. You just go, since you are in Assam, if you go to the eastern Assam, other side, Assam, or go to Manipur. So those areas, you will find this type of folds. Fault propagation folds or fault band. By definition, when there is a fault, when there is a movement between two blocks, a fold-like structure develops. Fold-like structure. That is what is called fault propagation fold or fault band fold. Because of faulting, the folds are developed. This is not like the folds which we have discussed earlier. Ductile folds. They are different. These folds are because of the faulting. Faulting is the cause of this fold. So these type of structures are generally developed, you know, in Himalaya areas. Himalaya. And these folds are the storehouse. You are seeing antiform here. Your antiform you are finding of petroleum. Petroleum reservoirs are found here. In these hinge zones. In these hinge zones. So Oil India, Indian Oil Corporation, ONGC, they drill in these areas. They put drill hole here and find out oil. Assam is famous for this oil. Norkati, Digboi, these areas. And long back, when English were ruling us, that time, the Indian geologists, they have found it out. That we have this type of structures, and in the hinge zone, you are finding the oil. Till today, those oil reservoirs continue. They are so rich in oil. So remember, for finding hydrocarbon oil, you should go for fault band faults or fault propagation. Because the oil can come from where? From the fossils. So fossils live in the marine environment. When they die, they fall on the seabed and then are buried. And whatever fluid they have, it comes out and remains within this antiform. So they form erosion or they form the oil. So in future, if you happen to work in some Assam oil field or that side oil field, you will be frequently coming across this type of structures. Fault propagation fault or fault band. Okay. Another thing related to fault. This is called salt tectonics. They are also famous for oil. See, in Himalaya, particularly Pakistan, Iran, Iraq, those areas, most of the oil, they are found associated with the salt. These red color pictures are salt. So oil occurs within this salt. Very close to salt, the oil occurs. So if you are working in an area where there are a lot of salt deposits, India it is not there. In Himalaya side it is not there. Assam it is not there. Arunachal Pradesh it is not there. You will get salt only in salt rains in Pakistan. They have taken from us. Now those salt beds, they form this type of antiform shell form. Because salt is a light material, it rises. So they push the overlying strata to form these folds. So oil occurs in these fold hinges. So be aware that salt is also very important. Not for only our food, we eat this salt. But same time also this salt is very famous, very important for oil deposits. Okay. This is also same picture, salt. So I will not give much attention to it. Now, this is a basin inversion, Just to remember this, some of the terms. Suppose in a sea, some sediments are deposited. What happens? The sea sometimes rises up. The basement rises up. And the sediments are brought up. That is called basin inversion. It's a very plain term I am telling. Details are there. So in those cases, some structural antiforms are developed. So those antiforms are famous for oil. So if this type of inversion structures are there, particularly in case of Assam, these basin inversions are. So you should be careful about these faults and find some oil. Okay. So this is all about the fault and fold. So let us go to ductile shear. I told you in the beginning, the ductile shear zones are also structures which are created below high temperature and pressure. Now see, this rock is a granite. You can see the quartz, feldspar. Quartz, feldspars are there. You see the quartz and feldspar. See, there is a narrow zone here. It is a ductile fault. Remember. But there is no sharp breaking, there is no detachment. You will find some fabric. This is called fabric. The layers like this, So this is called myelonite. This rock is called a myelonite. 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 So ductile shear zone consists of myelonitic rocks. Ductile shear zone consists of myelonitic rocks. Myelonitic rocks in the sense, rocks are deformed in a ductile manner along a narrow zone. That is a myelonite. Now go to the next slide. See, this is the myelonite zone. What fabrics are described in a myelonite? I do not know. In basic level, whether you have been taught these things, there is C fabric and S fabric. S combinedly it is called SC fabric. So in a myelonite, there are SC fabric. Which is C fabric? Parallel to the shear zone is C fabric. Angular to it is called S fabric. So this S and C fabric together, you can use to know the sense of movement. This arrow I have put, this is the movement. This block has gone up, this block has come down. This is called SC fabric. So this is the characteristic feature of a ductile shear. So where there are folds, you will also find the ductile shear zones there. Because both of them develop at the deeper level of the crust, where temperature and pressure is high. Okay. Now, you see, this is also myelonite. This is also a myelonite. I showed you SC fabric. There is one more feature in a ductile shear. What are they called? You can see these small features. The small features are there. They are called porphyroclasts. Porphyroclasts. There is two words: porphyroblasts, porphyroclasts. Porphyroblasts are metamorphic. Bigger crystals are there in a metamorphic rock. That you say is a porphyroblast. What is a porphyroclast? Porphyroclast develops in a ductile shear. So this is a ductile shear zone, this one, and these are the porphyroclasts. So this porphyroclast, if you just remove this part, this side here, you see this porphyroclast, it is something like this. It is something like this. You say this is a tail, this is a tail, and this is the core, this is the core, this is the tail, this is the tail. So from the position of these tails, you can say which way the movement has taken place. The faulting, the shearing has taken place. So this tail is, see, this tail is this side, this tail is this side. So I have put the arrow like this. So these porphyroclasts are the kinematic indicator. It is called kinematic indicator. Kinematic means movement. In a fault or in a shear zone, movement takes place like this now. Which way the movement? Right lateral or left lateral? What type of movement takes place? So those are called kinematics, sense of kinematics. So kinematic indicators is one of the porphyroclasts. You can use it to find the sense of movement. Now go to the next one. Here also the same feature you see. The same feature, you see, is a porphyroclast. There are several such porphyroclasts. Now these porphyroclasts I have drawn it here. So same, this is the tail, this is the tail. Here is another tail, here is tail. Now this is the core part, this is the core part. So this porphyroclast, if we take this tail position, taking this tail position, you can interpret which way the sense of shear has taken place. Which way the sense of shear has taken place, you can use this position of these tails. You see these porphyroclasts, it has a tail here, it has a tail here. This tail you see, this tail you see. So again the sense of shear is same. So when you go to a field, I told you, the field is such a subject, you require a trained teacher. So your teacher should show you first. This is the perforator class, this is the tail, this is the core. Then once he shows the things to you, your eye will be open. Then you will find many such shear zones. You will find many such perforator class. The sense of shear will be very easy for you to learn. Then how to sample a shear zone, how to collect a oriented sample in a shear zone. All those procedures will come one after another. One after another it will come. Now point is, while taking reading, while taking a sample, you should be very careful. You should meticulously take the reading, meticulously note them in the notebook. Otherwise, what will happen? Some data is missing and later on you cannot correlate them. You lose the link. So field work teaches you how to collect the data meticulously. And one after the another, you should note in a field diagram. And it is very perfect in this data. Absolutely no problem. Now, next slide, what it is showing. This type of photographs I have shown you earlier also. In case of fold, there I have told you the ladder van. But this is not a ladder van. Though they appear similar, but these vans, they are occurring in a ductile shear zone. Ductile shear zone they are occurring. So this is one ductile shear zone like this. There is another ductile shear zone here like this. And within the ductile shear zone, you are finding these vents. So these vents are called extensional vents or NSLN conjugate extensional vents. Conjugate in the sense this is one, this is another. This forms a pair. So shear zone, this thing happens. And you'll be surprised to note, these extensional vents are storehouse for many base metal deposits. Gold, platinum, silver. Point is, you should be able to identify these settings. The ductile shear zones you should be able to identify first of all. Once you identify the ductile shear zones, then quartz vents you can see in it. Once you see the quartz vents, go for sampling, and it will give you the values. Though it is very challenging, but it is quite enjoyable. Okay. Now, I will come to the thank you slide, but it is just a temporary closure. I will show you some of the things after this. Just I'll show you. Rudra. So you go to internet, better share kare jao. You have to write. Huh? Just a minute. Some advertisement has come. Who put this here? Now you say this.
No. Excuse me, sir. Are we audible? Are we audible, sir? Excuse me, sir. Are we audible?
So my point was, sometimes you find some time to see these YouTube videos. I have very meticulously recorded them in the field itself. Point by point, I have told how to collect data, how to record them, how to plot a position, how to plot your position, plot a station by taking depth bearing. Those things If you just go through this video, you'll be able to understand. And your idea will be clear. This is Tk Viswal YouTube field work. But there is one more Tk Viswal StereoNet also you can see. I told you, the StereoNet exercise, you know.
Excuse me, sir. Are you audible? Hello.
Hello, sir.
Yes.
Hello.
Okay.
Hello, sir.
Yeah. So you have several such things in the YouTube. You can have time and see them. So this will give a very clear picture, you know, how the field work is being done and how enjoyable it is. And many times, you know, there are problems and you have to sort out yourself. So with this, you know, I think I will conclude it here. And if you have some questions or any queries, you can ask. Please.
Hello. Are you audible, sir?
Hello, Manas.
Hello.
Hello.
Yes, sir. Yes, sir.
Just tell other if they have any questions to ask.
Yeah,
sir,
yes,
are
sir,
you-
sure. Yeah, students of Gorgaon College, yeah, do you have any questions to ask to Professor Tk Viswal? If you have any question, you can ask.
Can you hear us? Hello. Are you audible, sir?
Yeah, you are audible.
Yeah. It was very excellent talk, sir. And it was highly informative. I would ask my students to ask if they have any doubts. Does anybody have any doubt?
No, sir.
Yes, tell me.
First of all, very thank you for your valuable talk. My question is this: what is satellite in simple words?
Somehow I'm not able to follow, you know, it's a resounding, echoing. What is?
Satellite.
Manas, can you just tell me if you are able to listen properly?
There is some background noise. Who is there? Yeah.
So what is she asking? Can you chat? Can you write it?
Yeah, in chat box you can give.
I'm unable to listen you properly. What is saddle reef you are asking?
Yes, sir.
Okay. So in a fold, you know, in a fold near the hinge, if there is a fold near the hinge, there is some opening. Opening is created. So when this opening is created, the quarks from surrounding, they migrate and fill up that opening. So the opening is now filled up with quarks. Sometimes calcite is also filled up. So those quarks fillings in that hinge zone is called a saddle reef. Understood, na?
Sir, yes.
Okay.
So what is pigmentic fault?
What is beta axis?
Typing with
See, if you see this diagram, you can see this diagram.
Yes, sir.
Yeah. So what has been plotted here, you know, in this diagram? the strike and dig of this bed. I have collected strike and dig of this bed from here, from here, from here, from here, and plotted it in this diagram. Then I contour them. There is a process called contouring. I contour them. Then I am drawing a great circle at the center of all these contours. Great circle. This is called a great circle. And the pole of this great circle is beta. The pole of this great circle is called beta axis. This indicates that the axis of this pole, which way it is plunging, which is the trend of, what the amount of plunge. So this beta axis will tell you. So here you are not directly measuring the axis of this pole, but you are calculating the axis of this pole from this diagram, beta axis. That is why it is called beta axis. But the whole diagram is called a pi diagram. The entire stereo plot is called a pi diagram, and this pole of this girdle is called beta axis. It indicates the pole axis of the bigger pole. Is it clear? Yeah. Then one more is asking what is stigmatic fold. Stigmatic folds, very small folds, Stigmatic folds are very small folds. I'll show you the photograph again. Just a minute. Yeah. These are the small folds, So when there is a thin layer and you press it, that layer, is folded into small folds. And the axial plane of this fold is not constant. Some axial plane is towards east, some axial plane is towards west. And the most important feature of the stigmatic fold, in book you will get it. It is a negative interlimb angle. Generally, interlimb angle ऐसे होता है, it's like this. Sometimes the interlimb angle is negative हो जाता. It is a negative interlimb angle. So these are the three properties of stigmatic. It is very small wavelength. Some of the axial planes are tilted this way, some of the axial planes are tilted the other way, and it is a negative interlimb angle. That is how the stigmatic fold is defined. Then one more question has come, sir, how to identify mirror folds, coaxial folds in the interference? Very good question. Very good question. I'll just show you. Now, here is the interference patterns I have shown you. Now, in this case, I'll tell you just a minute. Now, just a minute. So this is a dome. ये dome है. This is a dome. This is a dome. Now, in case of mirror image, I'll show you how it looks like. The mirror image looks like this. Just a minute. It will be looking like this. Arc shape. Both sides connected. Arc shape. So it is called a mirror image. Because if you draw a line here, center, that is the mirror. That is the plane of symmetry. This is the plane of symmetry. This is the plane of symmetry. On either side, you are getting two hinges. One side this, another side this. This is a mirror image. And what about the coaxial fold? Coaxial folds are just a minute. Coaxial folds. Coaxial folds you see here. It is something like this, It is something like this. One side it is closed, the other side is open. This is F1 first fold, these are the second folds. But in case of mirror image, both sides it is closed. Both sides it is closed. That is mirror image. Dome is a spherical outflow, circular outflow. That is the distinction. And one more question has come. Hamiranjan, sir, as we know, Himalaya was formed by convergent plate boundary. I mean from collision, and for that Himalaya is fold mountain. So on the basis of that, can you say that Himalaya has maximum fold feature than other structural features? It has many folds, but sometimes also it has frost and fault. Because whatever structures we discussed today, fold, fault, and ductile shear joints, they are out of compression, out of collision, they are produced. Only at depth you will get fold, at the surface you will get fold, fault. But they are equally abundant. They are equally abundant. So it is not one is more or another is less. Everything you will get in Himalaya. Only point is you cannot do good field work in Himalaya. Because a lot of trees, a lot of steep hills are there. You cannot reach every spot. But you come to Aravalli, you will reach every spot. All the structures, fold, fault, shear joints, everything will get abundance. That is it. Sir, the outcrop of mirror image fold will be closed loop way. Mirror image will be closed loop way. I told you, na. But in type 3, coaxial, it will not close. Only one end it will be closed. Yeah, correct. Anything? Very good, very interesting questions you have understood. I am very happy. Many students are sitting in the audience. So are you able to hear me properly?
Yes, sir.
Okay. Okay. Come to IIT Bombay in future. Manas is here. He will help you in visiting IIT Bombay. You write JAM exam. Come to IIT Bombay. Write GATE exam. Come to IIT Bombay.
Thank you so much, Professor Tk
Okay. Okay.
for this valuable and sourceful talk.
Okay. Thank you.
And it enlightened us with the scopes of geology for fabric, for detail, and other information. And we are grateful to you for giving such a illustrative talk which gave us ideas on how geological structures are observed in field. Now coming to board of thanks. We are thankful to the principal of Program College, Dr. Saraswati Mahajan sir, for motivating us to organize the event and providing us the valuable help and support. We are thankful to Professor Tk Viswal sir for providing your valuable time to grace the event with a highly informative talk. We are thankful to Dr. Dimeshwar Das and IQMC Coordinator Dr. Swati Sekya for supporting us to arrange the event. We are thankful to all the faculty members of Cornell College and active participants for making the event successful. Thank you so much.
Thank you, sir.
Thank you. Thank you. Okay. We will see you sometimes in Mumbai. Okay. Okay, Manas. Everything fine. Now we can close.
Okay, sir. Okay. Thank you, sir.
Okay. Okay. Okay.